channels. And without further ado, I'd love to introduce the wonderful Sneha B. She's going to be taking us through the beginning session of SQL.
Hello, am I audible?
Yeah, are you able to share your screen?
Yeah, just a second. I couldn't hear anyone for a second there. Yeah.
I'm so sorry about that.
Yeah.
Bear with us.
Is my video visible as well?
Yes, we can see you, Sneha. Go ahead.
Oh, yeah. Okay. Hi, everyone, and a warm welcome to all of you for today's session. Today is our first session of the SQL Coding series, and I'll be your speaker for today. My name is Sneha, and I am an undergraduate student currently in my final year. I study at Bangalore, India, and I'm currently working or I'm pursuing undergraduate in computer science with artificial intelligence. So my main area of interest is actually artificial intelligence. And I'm really happy to be a speaker for today. And I'm glad to be talking about this session with you. So I guess without further ado, let's get started. And just a reminder again, if any of you have any queries throughout the session, please do put it in the Q&A box. So during breaks or towards the end of the session, we'll be able to help you with your queries. All right. Okay, so let's get started. Now here we're talking about data, right? So we now as humans, we deal a lot with digital media. We're on the web a lot, doing a lot of things. Either we're just simply surfing the net for some information or things like that, or maybe we're watching a few videos or looking at a few images, or maybe we're doing some online shopping on sites such as Amazon. No matter what, with every click of what we're doing, we're somehow generating some sort of data. And what companies do is that they take all of this data that we're generating, they somehow access it, manipulate it, and then are able to help us with our searches and help us learn better or search better. Like, let me give you an example. Take Amazon. So Amazon, let's say you are browsing for laptops on Amazon. When you're browsing for laptops on Amazon and you're done browsing through a lot, in the end, Amazon itself will be like, okay, for the people who bought such laptops also got laptop chargers or watches or things from a similar brand or, many other types of electronic items. So what is that? How is Amazon able to suggest something to you given, you were just surfing on that? That is through data, because you were surfing, you were doing some sort of searches on Amazon, or you were trying to look for something, or you purchased something from Amazon, and that was all data. And what Amazon did was simply take this data, analyze it, and give you your own personalized choices. So that's how data is right now the crux of every business. And data is what runs these businesses, and proper usage of this data is what help these businesses grow. So data comes in a huge variety of formats. So you have like relational databases, more of which we'll be talking about today. And data can also be like the pictures you upload on Facebook or Instagram, or some Word or Excel files that you use. All of this comprises of data, which is the crux of all businesses today. Now, what are databases? Databases basically help you manage all of this data. There's a large amount of data, and you need some sort of way for you to manage all this. And that's where databases come into play. And they're involved in almost all facets of our life. You use it at school, you somehow use it at work. And if you go elsewhere, for example, medical care or some other sort of government thing, all of these places, all of these organizations in some way or the other are dealing with databases. And the reason databases exist, the reason they were developed, was basically to manage large amounts of data and to do so in a very well and organized manner. So that's a little intro about what we'll be talking about in the rest of the session today. So now I kept mentioning the word data. And I'm sure some point in your life, you would have heard the word information. And sometimes the words data and the words information are rather used interchangeably. But is that right? Are data and information interchangeable, or do they have a distinction? So that's what I'll be talking about right now. Well, data and information do have a distinction. So what is data? Data is basically the raw form of facts that you obtain, facts that are just available to you, that are completely raw, completely unorganized. And if you just have data in your hand, you'll not really be able to learn a lot. You'll not be able to analyze or process anything as much because you just have this data and it's raw and unorganized. You cannot look at data and infer anything from that. So this data can be something like text or some sort of observations, some sort of signals, some descriptions, or some symbols and things like that. So that is what data is. And this data does not have exactly a specific purpose. It is just a fact, a figure, and a number. And this needs to be processed for you to be able to understand anything. And data, when you talk about computer science especially, this data is usually measured in bits and bytes. And bits and bytes are the basic unit of information or the basic unit of processing in terms of computer science. So that's about data. It's all raw and it's unorganized. And when you simply have this data, this text or a number or a fact or a figure, you're not able to understand anything. Whereas information, now information is basically processed and organized data. This data is something where you have that raw data and you apply some processing on it, and then you're able to extract something meaningful out of it. So let me take an example. For example, you're in a restaurant and you and your family eat, and based on how much you spend, some number of revenue is generated for that particular hotel or particular restaurant. But then with just that value, with just the amount of revenue that you were able to give to the restaurant, let's say, they cannot make any meaningful analysis. They cannot make any meaningful insights. Rather, they need a large amount of data because you're not their only customer. There are many customers coming to this restaurant, and many of these pay and help generate revenue for this restaurant. So simply using the data that you gave, the one that you gave, that particular number, that is data. And if we were to help analyze everyone's data, process it, and maybe do something like finding the most popular and the least popular dish, or finding the the dish that gives you most revenue for the company, or things like that, that is information. And this information can only be extracted from all this data. To give an even easier example, let's say you're a student in a class, and let's say, suppose you scored 100 marks in science. Now that is simply data. If you want some sort of information to understand, or if a teacher wants some sort of information to understand, hey, how's the class doing? They cannot simply take your 100 in science and say, okay, wow, the class is doing great because someone got 100 in science. No, they need to take the data from every particular student. They need to take the data, which in this case is the marks, for every student, analyze that, and then figure out what could be the possible information. So once that's analyzed, the teacher will probably analyze, okay, how many people got 100? If a sufficient people got 100, the teacher will themselves be like, okay, this class is done well. This class has understood the subject well. Or they would calculate the class average and see, okay, the average was well above 50, maybe it was 70. So that means the class is done well, or things like that. So that is the exact distinction between data and information. So if you have any doubts so far, please do put it in the Q&A box, and we'll definitely be happy to get to it. Okay, so now before we move and talk and focus our attention more on database management systems, let's have a little insight into the types of data. So there are mainly three types of data. You have structured data, semi-structured data, as well as unstructured data. So structured data is usually that data which you can decompose into rows and columns. That is structured data. And for an example of this is relational data, and more of this will be spoken towards the end of the session. And this is structured data is usually what we are going to deal with in this entire SQL coding series. But for your information, there are two other types known as semi-structured as well as unstructured. So semi-structured data is the data that has some form of organization. You've seen XML files where you have those angular brackets. You have some data that's present in some sort of format within those angular brackets, right? So that is semi-structured data. Okay, and so yeah, that's an example is it's not as structured as the structured data, as in it cannot be exactly decomposed into rows and columns, but it does have some form of organization. And an example would be XML files. Now, unstructured data, as the name suggests, is data that has absolutely no formatting, absolutely no organization, and it's very, very difficult to actually manipulate such data and even access such data. And some examples of that would be like image files, Word files, PDF, Excel files, and PDF, and all of those things. That falls under unstructured data. So we will mostly be dealing with structured data for the rest of this course. Okay, now let's talk about the main hero of our show, which is DBMS, or Database Management Systems. So what exactly is Database Management Systems? We spoke about data so far, how with every click that we do on the internet, so much data is collected, and how businesses need to use this data properly to be able to flourish. So because you need to be able to use this data properly, you need some sort of mechanism that can help you understand this data, that can help. Am I still audible? Because Lindsay's video is frozen for me. Hello?
Yes, you're audible.
I think everything's okay.
Yeah, okay. I thought my internet had a problem. Yeah, sorry, let's get back. So like I said, all businesses, they need some sort of mechanism to base, or some sort of framework to basically help you understand this data, store this data, access this data, manipulate this data. And that is exactly what a database management system does. It is basically a computerized data keeping system. It helps you store small or large amounts of data. And when you're storing that data, you may want to do other functions as well. So let me give you a basic example. Let's say again, a teacher wants to store all the different marks her students have gotten over the course of a semester. So what she does is she stores it all in a database management system. Now that she has all this information in a database management system, let's say there are 5 Snehas in her class, and she wants to find out what are the marks that all of these 5 Snehas have gotten in science. So to do that, she's basically accessing the data. And this accessing of data becomes very easy with DBMS. As we will learn further on in the course, we basically use something known as SQL, or structured query language, to write something called a query to access this data. Again, I will elaborate more on this towards the end of this session, but yes. So that is what DBMS does. So you have your data, which in this case, I said marks of different students for various subjects over the course of a semester. And you want to access this data. Let's say you want to access the marks that all the Snehas in the class got in science. So you can somehow do that using SQL. And now let's say there was a person in the class named Raj, and this particular Raj's mathematics marks were entered wrong, or by the teacher. The teacher entered Raj's marks wrong. Now you have so many students, right? You can't possibly go through every single student to figure out where is Raj, right? Rather, you want a mechanism that will help you find this Raj easily, find his mathematics marks easily, and then the teacher can, enter the correct mark there. So that and all of this, that is accessing a data, manipulating a data, can be easily done using database management systems. So like it was mentioned, several types of operations can be done. And database management systems are of many categories, and they're usually categorized according to their data structures or their types. And we will talk about each of their categories just after this. So before we talk about each of DBMS categories, let's talk about the difference between DBMS and flat files. So flat files are basically Excel. Now, I told you that, you have the marks of the students and marks of the students for every subject over the course of a semester. And let's say you want to access data or manipulate data. I'm sure many of you would have thought of an Excel instantly. Many of you, the image of an Excel would have popped in, because Excel also is rows and columns, right? So if you already have Excel, which is commonly known as flat files, can maybe few of you type into the chat, why do we need, based on what you've so far learned about DBMS, why do we exactly need a DBMS when we already have flat files? Whatever you think. Okay, for easy query, that's a really good answer. Yes, exactly. To enable queries, yes. To manage large data, absolutely. Yes, Excel files cannot get really big. Yes. Okay, there's a lot of answers. Excel would only be available in local systems. Yes. To search easily, absolutely, absolutely. These are really, really good answers. To reduce redundancy, that's a very good point, Susan. That is something I really wanted to focus on as well. Consistent information, exactly. Okay, so these are some really good answers, guys. I think you've covered most of what the differences are. So yes, as you all said, DBMS versus flat files. Let's look at the differences. One, DBMS is used for multi-user access. As someone so rightly mentioned, Excel files or flat files are mostly for local systems, right? Now, if we want to expand this and have multiple users use it, have an admin, have a user, and set those privileges and all of that aside, it would be better that we have a database management system, as this makes it easier. And database management systems, like someone also mentioned, can be used for much larger businesses that have much larger amounts of data that can be easily stored, accessed, and manipulated in database management systems. While for flat files, you cannot do that. It's for smaller and it's only stored on your local systems. Now, the very, very important point that I do want to discuss is removing redundancy and integrity. What does this mean? What do you mean by redundancy and integrity, or redundancy? Can anyone maybe give me an example if you can understand what's the meaning of redundancy in, let's say, a database management system or a flat file? Anything that you understand. I'll definitely elaborate on that, of course. Yes, repetitive information. Yes, absolutely. So having the same data repeated, exactly. Wow, okay, you guys are super knowledgeable. So yes, that's exactly what it is, repetitive information. So let's say in a class, right? Or let's say you have two different Excel files. One has the student's name as well as the student's mark. Another has, let's say, the student's name as well as the student's address. Okay. So now sometimes what happens is that the student probably entered their details wrong, as in maybe, let's say, they didn't enter their full name. They rather just enter their initial, and now they want to enter their full name. So what a teacher, if you have two Excel files for this purpose, let's say, the teacher goes to the marks file. And suppose I entered my name as Sneha and I want to make it Sneha B. So the teacher will go and make it Sneha B over there. But the same teacher will forget to do that thing in the address Excel file. They will do it for the marks, but they'll forget for the Excel. That means there exists a Sneha B who, let's say, has some sort of marks in the marks file, but there is no record of a Sneha B for the address. That means information is not consistent. There is a Sneha B here, there is no Sneha B here. And these two lists are supposed to be for the same set of students. So that is inconsistency. And let's say you're repeating information many times throughout all of these different tables or Excel files, that would be known as redundancy. And using just a few simple SQL queries, you can remove redundancy as well as maintain integrity of data. That is, maintain the consistency of data in DBMS. And that's why DBMS is more popular. So now some may say that DBMS is expensive, but given all the additional features it has, for example, like multi-user access or removes redundancy and integrity and helps you work with a large amount of data that will help you for larger businesses, given all of these perks, in the long term, it's okay for you to spend a little bit more on and have a DBMS, because that will help you access and manage as well as store the data properly. And in DBMS, if you have some sort of complicated transactions, or you have some sort of data you want to access and you have a very complex query to do that, it's easier to do that because you have SQL and you can basically write these SQL queries to access and manipulate your data. But with a flat file management system, you're not able to do that. So that is the difference between a DBMS as well as a flat file. Again, any doubts you have, please do ask it in the Q&A box so that we can help you answer that towards the end of the session. All right, now let's talk about the different types of databases. So the most common one that we have is a relational database, right? So relational database is the one where you have rows and columns, and you have the column names basically are attributing to what type of data you have, and each record of that data is stored as a row. So I'll explain with a picture in the next slide, but let's talk about the other different types before we move on. We also have something called an object-oriented database. Now, what exactly is this object-oriented database? Well, I'm sure some of you may be doing some sort of programming, or may in passing have heard the word object-oriented programming. Object-oriented programming is basically where you have things like classes or variables or methods, and these are the things that help you write your entire program. That is what object-oriented programming is. And when you talk about an object-oriented database, it also uses the concepts of classes, variables, and methods to basically help store and access your data. Then you have hierarchical database. Now, hierarchical database is basically represented as a tree, What do I mean by this? Well, you have the table name as the main parent node, and all the other rows and columns that would usually be represented as a table, you have represented as a tree. So the column names would be the child of this root node, and their subfields and their data would be their children, and goes on like that. So it's basically essentially a tree structure. And a network database is very similar to a hierarchical database, except rather than it being a tree structure, it's a graph-based structure. That is what a network database is. So these are main different types of databases that you have. And yes, so this is what a relational database looks like. So you have, this is how it looks like. This particular thing is usually the table name. And then you have, these are columns, and so these are the column names you have. And each record is usually known as a tuple or a row. And each column is known as an attribute. So you have these column names. And so this is basically a table where you have the roll number, the name of a student, as well as their phone number. So yes, this is known as a relational database. And you have a table name, the column names or the columns are known as attributes. The rows are known as tuple or records or relation. So that's how it's tables like this that we're going to deal with for the rest of the series. So yes, any doubts here? This is all very, very basic concepts. So if you have any doubts here, please don't hesitate in asking, and do put that in the Q&A box. All right, so let's talk about SQL right now. So what is SQL? Now we've spoken so much about what is a database. A database helps you store data. What exactly is a relational database, and how is that different from various other types of databases? Now that we have a database management system, or rather an idea of it in our mind, what exactly is this SQL? And how is this SQL going to help us with the database management system? Well, SQL first and foremost stands for Structured Query Language. And what this structured query language basically helps you do is it helps you write something known as a query, which is sort of like a code. And this code will help you access data, will help you manipulate data. This code will help you create different tables, will help you delete tables, will help you add more records, or it will help you do a whole list or a whole host of functions for the entire purpose of a database management system. So let's say, like I mentioned previously, you have one database, and in that database you have a student's name and their marks. And let's say again you have a student named Raj, and his mathematics marks were entered wrong, and you want to update that to a new value. So you have different names or syntaxes of queries that can help you do such a task, where you can go to in that database, you can access the name of a person named Raj and update his marks. So that is something you can do. You can access, manipulate data, and there are various other operations that you can do with data. Many other operations which we'll be talking about in the forthcoming sessions. And all of these operations are something you can actually do using this structured query languages. There are specific syntaxes that you can follow, and you can do that using this. And it also maps different tables to get data from various places. Now, that's one of the very prime advantages of both a database management system as well as SQL. What do I mean by this? So let me help you understand this with the help of this picture. So let's say you have a 3-table connection that follows this format, right? So you have a student's table, a student courses table, as well as a courses table. And as you can see, they're somehow connected. How are they connected? Well, students table has something known as an ID as well as a name. So the ID and a name correspond to each other. And the courses table has something known as an ID and a course, the name of a course. Now, the student courses table is something that kind of combines both these tables. So you have student ID as well as a course ID. Now, let's say I'm going to ask you a query like, find out what course Mary is taking. Who is Mary? We don't know who's Mary, right? But we don't know who's Mary given this table, right? We don't know who's Mary given this table. But using the students table, we can figure out that Mary is the person who has the ID of 2. So Mary has the ID of 2. Now let's come here. What are the courses that Mary is taking? That is, what are the courses that the ID number 2 is taking? So we can see that ID number 2 is taking course 3. And ID number 2 is taking course 4, which means what is course 3 and course 4? How do we figure that out? Well, we have this table. So course 3 is MongoDB, course 4 is Java. So thus we can conclude that Mary is taking MongoDB and Java. Wow, okay, I'm sure that was a lot, right? Because we were combining 3 different tables and we were trying to access the data that was there within these 3 different tables. But This becomes a matter of simply 1 or 2 lines of code when you use SQL. That is the beauty of SQL, or that is the advantage of SQL, because all of this, this is what I meant by complex queries. So what I meant by complex queries is that this, like, you have many different tables, they're sort of connected, and you want to access different types of data there. You want to do a lot of accessing and manipulation. You can write SQL queries to do that for you. So yeah, this was the example where you have different tables, and SQL helps you map different tables to get data from a whole variety of places. So, and in the forthcoming sessions, we'll actually be showing you the code as to, if given this sort of arrangement, how to access or how to print what are the courses Mary is taking. We'll show you, and we'll be typing out for you the same. So now, why should we learn SQL for data science, or why are we exactly using this SQL for data science? Well, SQL is a very commonly used skill in data science. Why? Because data science, as the name suggests, deal with a lot of data. And sometimes we get this data in the form of a structured format, and columns. And we need to extract such data. Let's say we
Neha, I'm gonna have you stop for a second and maybe repeat yourself just a bit. There was a bit of a interference, and we lost the sound a little bit. Just back up just at the beginning of the slide, I think. Is your sound working okay? Let's see. Okay, we're gonna hang tight. There she is. You're much better now. Yeah.
Yeah, sorry.
It happens.
Yeah, sorry. There's fine. From where was it kind of breaking, so I can repeat myself
Just
again?
at the beginning of the slide you are currently on, not too far.
Okay.
Yeah.
All right. Okay, great. And again, if because of my voice breaking, or if because of other internet connections, if anyone in the audience wants me to repeat anything, please do mention that in the Q&A box. So I'll be more than happy to repeat. So yeah, don't worry about that. Okay, so I'll just start the slide all over. So why do we need SQL for data science? Well, data science, as the name suggests, has the term data in it. That means somehow through lots of different sources, you need to be able
Sneha, we're running into the same interference again. It's breaking up pretty bad.
data. That
so
is
sorry. Okay, give us a moment to get this back on track. I'm going to try to see if she can get reconnected again. I apologize. We missed the last slide again. It started breaking up pretty bad, Sneha.
Sneha, try turning off your video. And if you want, Lindsay or myself can share the screen, and then you can just speak over.
Sure.
Hi, is it better now?
Lindsay, I think you can share your screen.
Yeah, the sound is better.
Okay, yeah, Lindsay, it's better if you share your screen.
Sure, let me pull up the presentation real quick.
And if it helps, Sneha, try turning off your camera. Maybe it'll just reduce the bandwidth.
Yeah, sure. Okay, I think I just have a couple more slides. Let me just see if this works that way.
Sure.
Okay, I'm also connected to my hotspot right now. Is my screen visible?
Yes, it is. Did you want me to go ahead and share, or? I think we're
One
okay.
minute.
I'll have it as backup.
Yeah, okay. Yeah, keep it open as a backup, but
Sure.
Am I audible?
Yes, you are.
Is my voice breaking or anything?
Not currently, no, you're good.
Okay. All right, I'll just mention
Thank
this again. Yeah, no issues. So do interrupt me if my voice is breaking. Yeah. All right. So again, why do we need SQL for data science? So data science, as the name suggests, has data in it. That means through many different sources, you need to collect this data, and then you need to perform some sort of analysis on it. And sometimes the data that you need to collect could be present in the form of an SQL table, or like, a relational database system, or like could be present to you in the form of rows and columns. And when it's present to you in that form, you need to know what is a database management system, or what is an RDBMS. How do you manage it? How do you write SQL queries so that you can extract the data that you exactly need for the analysis? And using this data, how can you basically prepare your, perform analytics and prepare this data for your pre-processing models? So all of this you need, and data is present in SQL tables. And that's why it's very, very important for all data scientists, or for people who are pursuing the path of data science, to know what SQL is, to understand SQL, and basically learn the different queries that are here. And that will basically help you easily with your data extraction process. So yes, that's why we use SQL for data science. And so I just want to wrap things up with this one image that will show you once again, or highlight once again, the importance of databases and how many does an average person interact with on a daily basis. So let's take a persona here. We have Susan. So before Susan leaves for work, she checks her Facebook and Twitter accounts. And there, when she's checking this Facebook and Twitter accounts, she's accessing some sort of database. In her lunch break, let's say she goes to a pharmacy and she picks up some medicine. Again, there, based on what the database that it's present at the pharmacy, she interacts with some sort of database over there. Now, let's say after she's done with her lunch and she picks up this prescription, and after her work is done, she goes to a grocery store. There also, there will be a different type of database that she interacts with. Okay. And let's say later on, she plans for a trip, and, because she's planning for a trip, she buys some sort of airline tickets, as well as she makes hotel reservations. Here, she will be dealing with two separate sets of databases here, one for airlines, one for hotel reservations. And again, let's say she makes some online purchases for her trip and she's all packed and ready. When she's making these online purchases also, she's dealing with some sort of databases. So you have, like, when she's with her Facebook or Twitter accounts, she has a database that has different users or her friends and their posts. When she's buying pharmacy, she has the pharmacist database, which has products, the sales, and the customers. Later, when she goes to the grocery store, again, she has another database that she interacts with that has products, which the products will be definitely different from the one at the pharmacy, and the sales and the customers. So similarly, even we go through, I'm sure, like, these activities that Susan's doing, many of us have done many times. So every time we do all of these activities, we're interacting some way or the other with a database that helps and stores all of this data. And that's why databases or database management systems are so important, because they're literally used in every facet of our life. They're literally used in almost every activity that we do on a day-to-day basis. So that's it for all the theory I had from my side for this session. Now I'll just give a small overview on to what we'll be doing in the forthcoming session. So this was just a simple basics onto what database management system is, what is a relational database management system, and what is an introduction to basically SQL, structured query language, and how can that help us. Now later on in, this will be an every Friday session until, at 10 p.m. Eastern time till February 10th. So in the next session, we'll be talking about high level CRUD as well as how SQL is used. And we'll also talk a little bit more about basic structure for an SQL query. We'll be talking about a few commands like select, from, where, limit. We'll also be talking about, conditional logic like greater than, less than, equal to, in, like, between. And we'll also talk about a few identifiers like is, null, and, or not. Then in the intermediate sessions, the first session, we'll be talking about a few functions like count, sum, average, min, max, group by, and case statements. And the second session of intermediate, we'll be talking about all the different types of joins that are there, like inner join, left, right, outer, and self. Then finally, we'll move on to some advanced concepts like multiple joins, subqueries, set operators, and things like that. So that's what we have for all the sessions upcoming until February 10th. So this is a recurring series occurring every Friday at 10 p.m. Eastern time. And you can make sure to find the time exactly for you in your time zone as well. Yes, and that brings us to the end of this session. So any queries, please do feel free to ask it in the Q&A box.
I do remember seeing a question in the chat. I'm not sure it got moved over to the main Q&A, but someone was inquiring about the difference between a database and a data warehouse. And I'm sure we can't give a very detailed overview, but maybe some quick answer to that would be helpful.
Sure. Okay. So I will just tell you based on my knowledge of this. A database is basically, let's say you have a particular business problem. Like if I go back to, if I go back here, you see, these are databases, because they are referring to one particular problem. So let's say you have, Twitter and Facebook account. So you have a particular database that has different users and their friends as well as their posts. So that is a database. Well, a data warehouse is on a much larger scale. It stores data not just for one business problem, but for a variety of business problems. And when you're doing something like data science, what you do is you go to a data warehouse and you look at the data available for your business problem and you extract that. So that's what I've understood. You have, like, for an example, if you're using AWS or other cloud services, you have something known as Redshift. That is one of the very popular data warehouses that are present. So yeah, that's a difference between database and data warehouse. If anyone in the panel would like to add on to my answer, please feel free to do so.
I think that was a great overview, unless someone has another clarifying question. We do still have a little bit of time. We're more than happy to sit here and answer questions for a few more moments if anyone has anything that's just burning on their mind they'd like to get sorted out. Otherwise, you're more than welcome to carry that over to next session. Next week, we have 4 more weeks of this, and we're very excited to continue learning. Thank you, Sneha B. That was an excellent presentation. I loved your energy, and it's so engaging to listen to you. We do have another question here. Yeah.
Yeah, sure. I'll just stop sharing my screen.
Sure.
Okay, yeah, I think a few more questions are coming in the way.
Yes, they are.
Okay, so someone's asked, what are the differences between the SQL dialects available in the market? So what do you mean by SQL dialects here exactly? Because I think, okay, what I feel is that this person may be confusing with the different database engines we have in the market, because we have different database engines like Oracle or SQL Server or MySQL, where, these database engines are basically act as a software where you can write SQL queries, and on the back end, they will be dealing with the database. So if that's what you mean, then we have a variety of database engines like Oracle, SQL Server, MySQL, PostgreSQL, and things like that. So, I mean, I hope that's the question you were trying to ask. If it's anything else, please do ask a follow-up question.
Excellent. It's an interesting question here about how do people present SQL reports? And I was going to go ahead and type it out, but I think it's a nice little discussion. So the question was, how do people present SQL reports? And so I guess that what to me that means, and go ahead and clarify this if I'm wrong, but maybe that means how do you present the findings of your queries?
Oh, okay. I think Lindsay, you were typing something. Maybe you can just say it out.
Sure. Yeah. Well, all I was going to say is that there can be done with a variety of tools people are comfortable with using, and also what the organization you're working for recommends or requires or prefers. But typically, you can do this in a PowerPoint presentation. Some people can present it in forms or Excel spreadsheets, CSV files, pardon me. And then also there's tools that can do visualizations as well, such as Tableau or Power BI. And some of those tools allow you to create more visual reports and presentations that you can present your findings in. And if anyone has anything to add to that, feel free.
I think, yeah, that basically summed up what I was also thinking as well. And yeah, that's a really good answer. So you have, I mean, you usually take this data sometimes to work with it later on in data science as well. So you mentioned CSV files and things like that. That's very commonly used in data science. So sometimes the whatever SQL you have been doing, that gets extracted and you make it CSV file and use it for data science. But yes, we also use it for visualization. Tableau, Power BI is something that's very common. And yeah, I think that was a really great answer, Lindsay.
Thanks. Well, we do have quite a lot of questions here. I think some of them are being answered in the chat box. So if we don't get to all of them, I apologize. Here's another one that I found interesting. How does SQL compare to Python or Excel in terms of speed from your experience?
Okay, so from my experience, and like I mentioned, SQL is basically used to write queries that will easily help you access and manipulate data that's present in a database. So if you rather simply store this data in Excel and you want to access that data in Excel using some sort of Excel formula, or like, write some sort of Python query to access this information in Excel, it won't be as fast because you won't get all the features that you have in SQL. In SQL, you can write the most complex of queries. Like I think if you remember back to the 3-table explanation I showed you, you have 3 different tables and you basically want to access data that, are joining all these 3 different tables. So all of that can be done easily within just simply 1 or 2 lines in an SQL query, but it may take more lines, more blocks, and more processing power if you're simply using an Excel or Python for the same. So yeah, that's how SQL is built in for such tasks. So it would be better to use SQL and have an entire storage as a DBMS rather than move to Excel or Python.
Great. Let's see. Here's an interesting question too. So before you start a project, do you come into it with a specific set of questions, or is the person open to possibilities, similar to prompting a chat GPT?
Okay, so I think they mean like a broad overview of projects, like any sort of project, So when you come into a project, you will definitely have a certain set of questions you need to ask yourself, because before you start a project, you will have some purpose for it. You will have some business objective for that project, right? Like let me, since we're talking about SQL, let's take to example an SQL project. So before you collect the data required to do an SQL project, and whatever this purpose of this SQL project will be, you will collect your data according to a business objective. Let's say your business objective was, to understand the average performance of the students in a class, or to understand the average salary of some employees belonging to a particular company. Then you will be collecting data that is like that. So later on, once you collect data like that, you'll analyze in that format, and then you will get your objective in that format. So before you start any project, you need to set your goals, objectives, and everything clear, so that you're later on accessing, or you're doing operations in that manner, and you're able to reach your goal. So if you just move into a project like, just like a prompt like you do with the chat GPT, that's not going to be very beneficial to you, because you'll not have a path to follow. You'll just be going in different crossroads and you won't know what to do. So yeah.
Agreed. I think that was a great answer. Here's another good one. Can you give an example of how an object-oriented database is different from a relational database? From the understanding that object-oriented is a programming logic. Go ahead. I'm sorry.
No, please continue. I'll just pull up this image I saw in the morning. So yeah, until then, please continue.
Perfect. Yeah. So you're correct. The object-oriented is it's a programming logic. So it's like Sneha mentioned, there are methods and variables and things that you're working with in the programming, and relational is how the tables of the data relate to each other. So that's how I think they would be different. Very basically, I hope that helps.
I think that's a really good answer. And I think, visually it always helps people if they understand. So let me just show you this image.
Perfect.
Yeah. So I think when I was presenting, I showed this image, right, from this source, where I said that, you have a table name and, wait, is my screen visible, right?
Yes, we can see it.
Yeah. Okay. So you have a table name, and then you have attributes, and then you have the records, right? Now, imagine this, but with respect to object-oriented programming concepts. So that will look something like this. So when you have a relation or a table, that can be modeled to a class. Let's say you have a tuple or a record, that will basically be like an object or an object instance. And a column will be a variable, and based on how you store it, that will be a method. So this is how you can, compare a relational model, or whatever you represent as rows and columns, or attributes and records, to object-oriented model concepts like classes or objects, variables, and methods. So I hope that helped you.
Visuals are always good. And the final question here is, when you mentioned OOP, are you saying that SQL is just like coding program language and uses the same logic? So it kind of rolls into what we were just talking about.
Okay, so I think, yeah. So when I mentioned OOP, okay, I think someone already answered that question, but I'll just tell you what my understanding is also. So usually when you talk about programming languages like Python or C++, they have a proper, object-oriented programming. They're an object-oriented programming language, and they're more of a general purpose language. That is, they can perform a huge variety of tasks, and they have the aid of object-oriented programming principles like making a class and things like that that help it ease of use, right? But with SQL is a programming language, but it's more domain specific. That is, you can't do everything with SQL. The only thing you can do with SQL is access and manipulate data that's present in a database. If you take Python, it's a general purpose language. That is, you can do anything with Python. You can not only do machine learning, you can do web applications, you can do gaming, so many things are there with Python. But with SQL, it's a domain specific language. You can only do for that particular one domain, that is accessing and manipulating data in a database. So I hope that helped.
I certainly think it covers it. Are there any other clarifying questions we can help the audience with? It seems like you did a wonderful job of coming up with really insightful, very poignant questions that we were really very much enjoyed answering.
Yeah, actually, it was really, really nice question.
Yes. Okay. I think we've probably given enough time then, and we'll let you go about the rest of your evening or morning or wherever you're at. It's probably close to your weekend. So I just want to say thank you again for joining us, and we're so happy to have you here. And we look forward to seeing everyone on the next session. Please feel free to register, and you can also, when you do register for all this series events at the same time. Okay.
Yes, we'd love to see you all there. So thank you so much for attending.
Thank you.